This course is about drawdown, reducing carbon dioxide, but there are also issues associated with renewables, which are meant for reducing carbon dioxide or greenhouse gases in general, require raw materials which themselves have other issues of overlapping with biodiversity and overall land use changes. So I decided to add this little podcast with some information on the kinds of things we have to worry about under energy in general. But it's fun to also look at the raw materials that are there with the ordinary things you use, like your iPhone, Starbucks cup, and bike. This is from a Dutch artist group which put this together. So the figures here are a bit murky, but they are artistic renditions, so don't worry about it. The iPhone 4S is made of specially developed glass along with steel, polycarbonate, graphite, copper, nickel, and a range of other materials. Nokia 3210 includes polycarbonate, acrylonitrile, butadiene, styrene, nylon, and aluminum. Its main component is the circuitry of an actual telephone. Internet 2020 is represented by a large block indicating the weight of all the electrons running through it, with a much smaller block showing how it appeared in 2000. So internet users numbers have gone up and will continue to go up, and we have looked at the carbon footprint of SMSs, emails, WhatsApp messages in other contexts, but this gives you an idea of just how much we are dependent on the internet now. The Big Mac menu features water, bread, fries, Coke, fat and meat, and other ingredients that people do recognize, as the nota says. Starbucks cup is mostly water, but also contains paper, coffee, wood, and polystyrene. An AK-47. The AK-47 consists of birchwood, steel, paint, and other materials, while the bullet contains steel, smokeless powder, lead, and more, as compared with high-grade polymer and nickel bullets of the M16. Okay, that's the artist's nota. The bike, which unlike the smartphone is something people can dismantle themselves, is made of rubber, polyurethane foam, steel, aluminum, and other materials. Now you have more and more carbon materials as well going into bicycles. Okay, so that gives you a sense of just how you're holding a little cup or iPhone, and God forbid you are not holding an AK-47 unless you are a soldier. The kind of things that are in there, we are not even close to being aware of the details, but all of that material mostly comes either from industrial production or mining. And surprisingly, even the renewable energy requires incredible amount of minerals, metals, and other things that are mined across the world. And we have talked about the problems of recycling solar PV cells once their life cycle is over, or the windmills once their life cycle is over, and how they're going to keep piling up as well. So the life cycle analysis, end-to-end analysis, is always critical. This paper looks particularly at the mining for critical materials for renewable energy systems, and it cautions us that while we are very keen on expanding renewables to replace fossil fuels at a faster and faster rate, we must also worry about the mining that will be required to produce those renewable systems. Okay, so global mining areas and their density for critical, mine density for other, and both. So here mining areas were mapped using a 50 cell radius around 62,381 pre-operational, operational, and closed mining properties. Mining areas with properties targeting materials critical for for renewable energy technology and infrastructure are shown in blue, this range of colors in terms of numbers and densities. Areas with properties targeting other materials are shown in orange range colors, and those targeting both commodity types are shown in this pink range. Color shading light to dark indicates the density of mining areas, that is, the number of mining properties within a 50 cell radius of each 1 kilometer cell. So you can see there is both tremendous mining here down all the way the west coast of South and North America, a bunch here in Canada, northern US, in the middle here, so, and Africa, which is basically exporting its wealth and remains largely poor, Europe, Siberia, Russia, China, India, all these Southeast Asian countries, Australia. Look at the density of mining here, right? So the world is being dug up for materials that are critical for renewable energy technology and infrastructure, and we think it's exciting news that renewables are growing in their market share, but this problem has to be kept in mind. Another way to look at it is to look at proportion overlap between mining and biodiversity conservation. In the mining areas, protected areas, key biodiversity areas, and remaining wilderness. In the non-mining areas, the same overlap between protected areas, key biodiversity areas, and remaining wilderness. The overlap is smaller in the mining areas. Okay, so you have to also then look at the overlaps between critical protected areas, biodiversity areas, and remaining wilderness in terms of critical, other, and both. So critical materials for renewable technology and infrastructure, other minerals that are needed for everything else, like the iPhone, Starbucks cup, AK-47, your car, computer, everything else, and materials that are being dug up, mineral mining for both of them. So proportion overlap for pre-opening, operating, and closed for critical, other, and both. And the point is that the risk that the mining areas have a higher overlap, proportion of overlap for critical materials for renewables than other. In most cases, you can see the green is critical, so whether it is protected areas, key biodiversity areas, or remaining wilderness areas, generally critical materials for renewable energy infrastructure and technology are larger in proportion than mining areas for other and both. So which just means that as we keep on wanting to increase the installed capacity for power generation from renewables, the mining and overlap with key biodiversity areas and protected areas for critical materials is going to keep growing. So while it will help with the reduction of greenhouse gases and phasing out fossil fuels and so on, it will bring other land use, land change issues, and loss of biodiversity and protected areas. So this is something critical that must be watched. So I'm putting it here in the energy sector just to warn ourselves that everything is not so hunky-dory. I could also put this in other places under land use, for example, or in another course on carbon footprints of everything we do, etc. But it doesn't matter. I can repeat these elsewhere as well. Okay, so just keep these things in mind as you get excited about renewables. There is the whole life cycle analysis and recycling of the materials of like solar cells and windmills after their life cycle is done. and all the minerals that are needed for them and where they come from, and exploitation of poorer countries for these minerals. There's lots of debate about whether China is taking over all the energy resources in Africa, what are the consequences, and whether it leaves behind anything for the future or just simply takes everything and leaves. Of course, everybody is in this game, but China is a big machinery now with the largest growing economy, so obviously everybody pays attention to it. But China also manufactures a lot of things for other countries, so there is the embedded trade issues as well that we discussed in other carbon footprint and environmental impact issues. Okay, just some general points, but they are worth remembering.